Welcome to Lionheart Academy. My name is Richard Tai. We're coming back to our trigonometry lessons. We're continuing our discussions in functions of any angles, which is basically we're talking about the trigonometry functions of any angles that can be conceived of. So it's not just limited to any acute angles, but we're talking about any angles. And the foundation of that is we use a coordinate plane to develop the definition of sine, cosine, tangent, and any other trig functions based on that coordinate plane. Now, so far in the previous lessons, we have discussed many basic numbers, function values already for those functions. So today we'd like to do a little summarization. I like to go ahead and present some of the patterns that we see based on those for the major angles. Okay, so today let's go ahead and develop some kind of summarization. And so let me go ahead and create the table, and then I'll be back in a minute, and then let's go ahead and discuss the values and summarization of what we have talked about so far. Okay, so now we're back. As you can see, I've created a table, and let's go ahead and label the columns with our functions, the functions that we're going to be talking about. Okay. So we have 6 basic trig functions. There are more, but we are going to stick with the 6 for now because they're the most commonly used. If you go on to advanced mathematics, you may be able to use more. Okay, and we're going to talk about, let's go ahead and start with 0 degrees, 30 degrees, 45 degrees, the most important angles that you really need to know. If you go on to take calculus, pre-calculus, calculus, well, trigonometry is part of calculus, but in different curriculums. But the most important things you need to know is actually what we are talking about here is the one we listed, from 0 all the way to 270. Well, you can add another column for 360, but 360 is just the same as 0, so we're not going to do that. Now, let's go and also put the radian. The radian is 0. Radian here is pi over 6, pi over 4, pi over 3, and then 90 degrees is pi over 2, 180 degrees pi, and then 273 pi over 2. So we have a good reference for everything here we have. The first quadrant and also the quadrant angles, the 0, 90, 180, 270 are the most important angles you really need to know. So there is a very simple way to not just memorize this table. As you can see, this table will be big. We're going to fill them out, but we don't have to memorize them per se. Okay, there's going to be a pattern. Let me show you that in a minute. But let's go and fill this out. So as we remember, sine has to do with the opposite leg over the hypotenuse, or sine has to do with y over r. Okay, so in this case, we're going to use that to fill this out. So it's going to be sine of 0 is going to be 0. Cosine, we have developed y sine of 0 is 0 and y cosine of 0 is 1 in the last video. So you can go back if you have missed that. And sine of 30 degrees is 1/2. Okay, and sine of 45 degrees is square root 2 over 2. And then we have square root 3 over 2, and then 1. Okay, and for cosine, it's actually the opposite. It went through the opposite cycle. This cosine of 30 degrees square root 3 over 2, cosine of 45 is the same, and cosine of 60 is 1/2, and cosine of 90 degrees is 1. Now for 180 degrees, sine will return to 0. For 270 degrees, sine is -1 because 270 is down there if you remember the quadrant angles, and then this one is -1, and this one is for cosine is 0. Cosine of 180 is -1, cosine of 270 is 0. So this is the beginning, arguably the most important part that you need to know, because every other function can be derived using sine and cosine. Okay, we're going to go ahead and talk about their relationship in a little bit. We did mention that there are reciprocals, and tangent is the quotient of sine over cosine. So to find tangent, all you need is know sine and cosine. You divide them. Tangent, again, we're going to say this over and over again, is tangent is sine divided by cosine. So let's see what's tangent. Okay, tangent of 0 degrees is sine divided by cosine. So 0 divided by 1 is 0. What about 1/2 divided by square root 3 over 2? Well, it's 1 over square root 3, but it can also be written as square root 3 over 3 when you rationalize it. Square root 2 over 2 divided by square root 2 over 2. Well, they are the same number, so it's equal to 1. What about this? Square root 3 over 2 divided by 1/2. Well, the denominator is the same, so when you divide the numerator divided by denominator, it's just square root of 3 divided by 1. And then 1 divided by 0, that's the thing, is we don't have 1 divided by 0, so it's undefined. So this is undefined. 0 divided by -1, 0, 1, -1 divided by 0 is again undefined. So tangent is undefined at 90 degrees and 270 degrees whenever cosine is equal to 0. Tangent is undefined. Now secant is the reciprocal of cosine. So if I know cosine, I do the reciprocal. Basically means I flip it, I do the reciprocal, then I'll get the same value of secant. I'll get the value of secant by finding the reciprocal of cosine. So secant of reciprocal 1 is 1. Reciprocal of square root 3 over 2 is 2 over square root 3. But if I rationalize it, it can be written as 2 square root 3 over 3. The reciprocal of 2 over square root 2 is just square root 2. Okay, so I'm going to write square root 2. So reciprocal of 1/2 is just 2. Reciprocal of 0 is undefined. There's no reciprocal of 0. Reciprocal of -1 is -1. Reciprocal of 0 again is undefined. Okay, cosecant happens to be the reciprocal of sine. So cosecant of 0 is undefined because there's no reciprocal of 0. And reciprocal of 1/2 is 2. Reciprocal of square root 2 over 2 is square root of 2. Reciprocal of square root 3 over 2 is 2 square root 3 over 3. Okay. And then reciprocal 1 is 1. Now you can see the pattern between sine, secant, and cosecant. They're also opposite of each other. They go through the opposite cycle. The reciprocal of 0 is undefined here, and the reciprocal of -1 is -1. And cotangent is cosine divided by sine. So instead of so it's reciprocal of tangent, cosine divided by sine. So reciprocal of 0 is undefined, and the reciprocal of square root 3 over 1 over square root 3 is square root 3 over 1. Reciprocal of 1 is still 1. Reciprocal of square root 3 is 1 over square root 3, so which is square root 3 over 3, which is correspond to tangent of 30 degrees, because the cotangent of 60 corresponds to tangent of 30, which agrees with our cotangent relationship as well, cofunction relationship as well. Remember cofunctions, if I have two cofunction the cofunction values are the same. If you're talking about two angles, they are complementary. Alright, tangent here is undefined, but it's actually tangent is sine divided by cosine, so cotangent is cosine divided by sine, so 0 divided by 1 is 0. Okay, and -1 divided by 0 is undefined. Okay, and then 0 divided by -1 would be 0. And then if we keep going 360 degrees to come back to repeat 0 degrees. So all that we really know, all that we really need to memorize is from 0 to 90 degrees. Now we do need to remember 180 and 270, but that usually is quite easy to remember. But this is the key, okay? The middle part, the part that's really in the middle, this is the, let me highlight that. This is the part that you really need to commit yourself to memory. And there's a very simple way to remember. As you can see, sine of theta is from 0, okay? And you can imagine actually you can do square root of 0 over 2. So then square root of 1 over 2. Then 45 degrees square root 2 over 2, 60 degrees square root 3 over 2, 90 degrees is square root 4 over 2. Square root 4 happens to be 2, so 2 over 2 is 1. So this same pattern is reversed for cosine. Cosine goes from square root of 4 over 2, then square root 3 over 2, square root 2 over 2, square root 1 over 2, and square root of 0 over 2, which is 0 over 2, which is 0. So this is the main thing, because everything else can be derived from the information that we have. Okay, so another let me go ahead and write this out like this. So if you have another way to write this, let me go ahead and write it in red. So you can consider this as square root of 0. So basically we start with square root of 0, square root 1, square root 2, square root 3, square root 4. Okay. okay, and if everything divided by 2. So square root 0, you start with sine, always start with 0, and then you have square root 1 over 2, square root 2 over 2, square root 3 over 2, and you can view this as square root 4 over 2. Okay, and same thing here for cosine, it goes back from 1 down to 0. Okay, so that hopefully that will help you memorize it a little bit better. Okay, all right. Now let's go ahead and take a look at another way to really understand some functions of any angle. It's called the unit circle, which is very, very useful. Okay, so let's go ahead and scroll up. Let's talk about the unit circle. Now, what is a unit circle? Well, a unit circle, by definition, is a circle that has a radius of 1. Okay, so but we're going to superimpose a circle on the coordinate plane, and we're going to see how that helps us understand the functions of sine, cosine, and tangent. How the unit circle helps us understand a trigonometry function. Okay. Alright. Alright, so if the radius of this circle is 1, unit circle is a circle with r equal to 1. So the radius is equal to 1, okay? That means from the center to this point is the distance is 1. So the origin is 0, 0, okay, and this point on the x-axis is 1, 0 because the x-coordinate is 1, the y-coordinate is 0. On the top here, the y-coordinate is 1, but the x-coordinate is 0, so 0, 1. Okay, over here, the x-coordinate is -1 and y is 0. And down here, the x-coordinate is 0, but y-coordinate is -1. So you can see everywhere is the radius is 1. Okay, so what does that mean? That means that if I go ahead and draw a radius like from here to here, for example, if I draw a radius here, this distance will be 1. Okay, so this point on the x-coordinate and the y-coordinate on the circle, the x-coordinate and y-coordinate on the circle, will give us a very special meaning. Now, why is that? Now, do you remember we define the functions of any angle using this kind of setup? So the x side, the x distance, so the x distance here, let me go ahead and try to draw that accurately. The x distance of that coordinate is this green segment, and the y distance is represented by this red segment. Alright, so let me go ahead and draw that a little bit here. So as you can see, this triangle, in this right triangle, you have the opposite side of the angle represented by y, the adjacent side represented by x. Now, do you remember the definition of sine and cosine? Definition of sine is the opposite leg divided by hypotenuse, right? Or y over r. But r happens to be what? 1. So sine of theta is just equal to y, because y is the opposite leg. So this physical measurement from this distance to this point, the vertical distance from the point down to the x-axis, that represents the actual sine value. This actually represents the value of sine theta. Okay, and the x distance actually represents the cosine value of the theta, because adjacent, right? Adjacent over the hypotenuse is your cosine. So cosine of the angle is the actual measurement of the x. So what we're looking here is an actual representation of physical representation of what the sine theta really mean. So this segment length really is sine theta. This segment length really is cosine of this angle theta. And so as I change theta, the cosine and the y, the x value and the cosine y value changes. So that means every point on the circle give us a coordinate. The point on the coordinate of the point give us two values, cosine and sine. So this is what unit circle is about. unit circle is that if we look at the unit circle, anywhere I put any point on the circle will give us a cosine reading and sine reading, because we have the x coordinate and y coordinate, and the x coordinate it corresponds to the cosine and y coordinate correspond to the sine. Okay, so the unit circle becomes a very powerful tool because it will allow us to understand, okay, y and sine and cosine in terms of this circular in terms of physical measurement. So sine and cosine is not just doesn't just give us a ratio anymore. It actually gives us a segment. It's a segment length on this unit circle here, because the radius happens to be equal to 1. So, and this will also give us a tool that which we can tabulate or understand the measurement of sine, cosine, and tangent using this unit circle. So we can create a unit circle here, as you will be able to see. We can go ahead and create our own unit circle. There are unit circles online. You can look it up. Just type in on the internet and search up. They will give you a complete unit circle. But let's go ahead and talk about what does that mean. Okay. Alright, so let's go ahead and look at this unit circle here. So imagine our initial side here. Our initial side, okay, is on the initial x-axis. If we don't rotate, it's 0 degrees. If we rotate here, it's 90 degrees. If we rotate here, it's 180. If we rotate here, it's 270. And if you rotate here, back here, it's 360 again. So that means the positive x-axis represents 0 degrees, and the positive y-axis represents 90 degrees. Negative x-axis represents 180 degrees, and down here this represents 270 degrees. And then when we come back here, it represents a whole completion of rotation. A complete rotation is 360 degrees. So those are the ways that we can start labeling the angles. Now we're going to use the radians a little bit better later. Now halfway through 90 degrees, we have 45 degrees. Now do you remember the definition? We just talked about 45 degrees, right? So if we talk about 45 degrees, the sine of 45 degrees is square root 2 over 2, and cosine of 45 degrees is also square root over 2. What would the order pair of this point be? Well, it will be square root 2 over 2 and square root 2 over 2. The reason is this is 45 degree angle. Now, before we go on to talk about the other angles, did you notice that, okay, for 0 degree, the order pair for the coordinate for the point for 0 degrees is 1, 0. Well, what does that mean? Well, this 1 represents the cosine of 0 degrees, and this 0 represents the sine of 0 degrees. For 90 degrees, this 0, 1, the first order pair is the x-coordinate. So this 0 represents the cosine of 90 degrees. This 1 represents the sine of 90 degrees. So by looking at this circle, by looking at the order pair of this point at the terminal side of the angle, right? This is the terminal side of the 90 degree angle, and this point is on the unit circle, 0, 1. That will give us the sine and cosine value, the exact sine and cosine value of this angle without further dividing anything, because the radius is always 1. Here, same thing. This is the terminal side of 180 degrees, and this point is negative 1, 0, right? And so the cosine value of negative 180 degrees is negative 1. The cosine value of 180 degrees is 0. Same thing for 270 degrees, okay? And so we also want to go ahead and add radian value according to their degree value, so we don't want to forget about radian. 45 degrees is pi over 4. We got to get ourselves very familiarized with ourselves with radian as well. Okay, I'm just gonna do 2 more. Okay, so let's do 30 degrees. 30 degrees is before 40 degree, 45 degrees. So the point for 30 degrees will be, this is going to be the first coordinate is going to be the cosine of 30 degrees, which is square root of 3 divided by 2, and cosine of sine of 30 degrees is going to be 1/2. So this point will have the order pair of square root 3 over 2 and 1/2, and this is pi over 6. All right, let's do one more. Okay, and for 60 degrees. Okay, as you can see, we're running out of time, running out of space a little bit. For 60 degrees, the cosine value will be 1/2, and sine value will be square root 3 over 2, so that will be 60 degrees is pi over 3. And as you can see, the progression for cosines goes from 1 square root 3 over 2, square root 2 over 2, square root 1 over 2, and square root of 0 over 2. Because the x coordinate actually goes from, you see, from when you're over here, x is 1, but when you go over here, x coordinate is reduced. The x distance is reducing, and down to here, there's no more x anymore. So the x coordinate becomes 0. But you do the opposite for y, which represents the sign. So from 0, go to 1/2, go to square root 2 over 2, go to square root 3 over 2, go to 1. And this is the most important quadrant, because later on we can reflect this values to the second quadrant, third quadrant, and fourth quadrant. Alright, so next time that's what we're going to do. But today, I guess this is it for today. So if you have any questions, please remember to leave a comment, and remember to leave any suggestions on the comment section. And then we look forward to see you again in our next lesson.